In this question, we're told, given that the quadratic equation 2k minus 3x squared plus 8x plus 2k plus 3 equals 0 has no real roots, show that k satisfies an inequality of the form m minus nk squared is less than 0, where m and n are integers whose values are to be found. Hence, find the range of values k such that the quadratic equation 2k minus 3x squared plus 8x plus 2k plus 3 equals 0. Okay, quite a lot of information here for what is a standard question. The key part to this question is really this bit has no real roots. This tells us that we're working with the discriminant, and in other words, because it's got no real roots, b squared minus 4ac has to be less than 0. So the fact that we're discussing roots of quadratic tells us it's a discriminant, and the fact that there are no real roots tells us that it must be less than 0. It's always worth stating your values of a, b and c to make sure you're clear on what you're going to substitute this into it. So a is 2k minus 3, b is 8, and c is 2k plus 3. Remember to keep these in brackets, it helps when working with them in b squared minus 4ac is less than 0. So essentially, while there's a lot of information there, all it's doing is breaking it into stages. First of all, it's saying we want to show it, form an equation of this structure circled here, and then actually solve to find that range of values. So substituting in b, I get 8 squared minus 4 times a, which is 2k minus 3, times b, which is 2k plus 3, all less than 0. So working through this, 8 squared is 64. I'm going to expand this bracket before I worry about the coefficient and multiplying it out before. So 2k times 2k is 4k squared. 2k times plus 3 will cancel out minus 3 times 2k, so this is a difference of 2 squareds. So really all I now need to do is minus 3 times plus 3, which is minus 9. And this is all less than 0. So now I need to expand out the bracket, so I get 64 minus 4 times 4k squared is 16k squared. Be careful on this one, minus 4 times minus 9 is plus 36, less than 0. And so we finish off at this stage, and we're going to get to this stage now where I can write this as 64 plus 36 is 100 minus 16k squared is less than 0. So at this stage I've now satisfied that requirement to write it in the form m minus nk squared is less than 0. So let's rearrange this and actually solve it. So I'm going to add the 16k to both k squared, to both sides. So to get 100 is less than 16k squared. And I'm going to divide by 16, so that in the end I get k squared is greater than 100 over 16. Now this is the difficult part, because actually solving an inequality here makes no sense. What I actually want to do is I just want to solve k squared is equal to 100 over 16. So let's take the square root of both sides. So I get k is equal to plus or minus square root of 100 is 10, and square root of 16 is 4. So actually we get k is plus or minus 5 over 2. So what I know at this point in that case is that I have a quadratic whose roots are plus or minus 5 over 2. So if I was to sketch that quadratic, it's a positive quadratic. So let's sketch that quadratic. It's not a great sketch. What I know is that we have a root here, minus 5 over 2, and I have a root here, which is 5 over 2. Y-axis would be in the middle. I'm looking for when k squared is greater than this value. So let's just get a highlighter pen, and what I'm going to do is I'm going to highlight the part of the graph which is greater than 0. So this part of the graph here above the y-axis, above the x-axis, greater than 0. This part of the graph here above the x-axis is greater than 0. So the x values that I'm interested in are the x values that generate that part of the graph. So I'm looking at the left-hand tail of the x-axis and the right-hand tail of the x-axis. So finally, all that's left to say is that for this left-hand tail of the x-axis, x must be less than minus 5 over 2. And I have to deal with this right-hand tail here, so x must be greater than positive 5 over 2. And it's really important at this point that these are two separate and distinct regions. They cannot both be true at the same time, so we must put in the fact that it can be one region or the other region. Okay, so let's have a look to see how this question is marked. First of all, there is a method mark for indicating the correct relationship between the discriminant and 0 for no real roots. Next, at this line here, we have a method mark if you've attempted to substitute in the values and have got at least 2 of these terms correct, and you get an answer mark if you get all 3 terms correct. Next, we get an answer mark for a convincing argument getting to the stage 100 minus 16k squared is less than 0. We then get a standalone mark for getting the critical values, these roots of the equation, for my sketch, and it must be equals at this point in time. And then finally, we get a standalone mark if we have stated the correct inequalities with the correct use of the word or to make sure that it's clear that there is one solution or the other. Okay, well I hope you was able to follow my solution and that you understood how to mark that question.